This is a walkthrough of the IMUS Metaverse server for the Vicadia project. It provides an overview of the organization of IMUS and its internal structure. And this is for developers to be able to add new features and find bugs in IMUS. It does not explain how to configure or run IMUS, the Metaverse server, but that'll have to be a different video. So we'll be covering topics in this outline, and to make the video easier to navigate, there'll be a section down here at the bottom of the screen which lists the topics, so you can easily skip forward to the sections you want. This information is also available inside the IMUS source tree. There's a docs directory, and inside the docs directory there are design documents which talk about routing, how to build it, and also its overall structure. So this information is written down as well as in the this video. So as a quick overview of where IMUS sits, for the Vicadia project, there's a thing called, there's interface and domain server. The interface provides the interface to the user, whether in their VR headset or on the desktop. And the domain server simulates the virtual worlds. And the domain servers talk to the Metaverse server, which is where IMUS sits. And the Metaverse server provides various services for the domain servers, inter-domain server communication stuff through the ICE server, authentication, and also accounts. Now the interface between the domain server and the Metaverse server is a simple REST API. So the domain servers make requests to URLs at the Metaverse server and get the responses back. And it's all in JSON. So in section 1 we will cover the language, the toolchain, and some of the coding conventions used in IMUS. So IMUS is developed with Visual Studio Code, although it can be developed with other things. Here you see Visual Studio Code. It gives the source tree and tabbed views and things for editing the source. It's a very nice development environment. So IMUS is a Node.js application, which means it's all JavaScript, and it's made for running on a server. A Node.js application is defined by its package.json file, which gives information about the application, gives all the commands for building and running it, and also lists all its library dependencies. So the package.json file takes the place of CMake and configuration used in other Linux systems. So to build and run IMUS, you first clone the repository. Then you have to add a configuration file which gives information about the Metaverse server and also its connection to the account for connecting to the database, and also other configuration information. So you've installed Node.js, which is a usual package on Linux systems, and Node.js gives you the command npm. So if I do an npm install, that reads the package.json file and downloads and installs all of the dependent libraries. So npm run build runs the build instruction that's in the package.json file to build it, and then npm run runs the run command, and voila, you have a running IMUS server. So IMUS is also uses TypeScript. Now you don't have to install TypeScript because TypeScript is just listed as a dependency, development dependency down here, and So what TypeScript is essentially a wrapper around JavaScript that adds typing. So if we look at this, here's a simple function called clamp. You can see this function takes 3 values and they are defined as type numbers, and this returns a number. So it adds typing information and makes JavaScript development a lot easier, in that you see integrated with this development IDE, you get typing and typing completion and all that sort of stuff done for you automatically. You can also define your own types, and I've defined some types for use inside IMUS. But in general, the files are named with .ts instead of .js, and what happens is the run command runs TypeScript on it, which compiles all the JavaScript or all the TypeScript into JavaScript into the dist subdirectory. So this is using the ES6 form of importing for JavaScript. If we look at this clamp function, you can see that he's importing other function from other places. So this is the format rather than using the require syntax. So it's the latest and greatest stuff. So you can import from all the little library packages, and you can rename things as they come in and all sorts of fancy stuff. IMUS also uses extensively the promise and await async JavaScript operations. So here's a simple example of a function, get file size async. So it has to open up the file and to get its size, which will be disk operations. So normally they'd put a callback in here. What this construction says, then return the size and then do this function. So this is kind of the success callback. And then there's a catch clause which does the exception callback. There's an even shorter form which you'll see as await, which calls the function, and using the success one, which returns the size. So this waits. This line will wait until this function finishes and completes and returns the successful size before doing the assignment. So this wraps all the callbacks and the threading that happens in JavaScript. Since JavaScript is a single-threaded application, you can't wait for things. You need to do everything with callbacks, and these are syntactic sugar to make the callbacks easier to read. All right. Section 2 talks about the base structure and most importantly the routing, the REST request routing stuff. So first of all, configuration. Configuration is handled by there's a file called config at the upper level of the source directory, and config has creates a structure that has all of the parameters that IMUS uses. And so this is the start, all the default values for things like server ports and how long heartbeats take, and all these parameters are here. And then what happens is that at init time, those default values are overlaid by environment variables, and then it reads a user configuration file, which was that imus.json file, which is the default file name that you saw earlier, and so it overlays that, so it replaces any value that's in this configuration listing. Logging is handled also by a bunch of libraries. So there's a log function that happens everywhere, and it's the usual logging of log level of debug, info, warn, and the library it uses creates rotating log files, so you don't run out of disk space necessarily. And then back behind IMUS is a database system. It uses MongoDB as the database, and the under tools, DBTS is the interface to MongoDB, and so he has all the functions to create an object, get an object, update the fields for it, and get collections of objects. Now MongoDB stores and searches JSON documents, so like the collection of accounts is multiple JSON documents. In particular, it can be any JSON, in fact. The tables are not strategically defined like in SQL and that sort of thing. But in this case, the accounts collection is all the same sort of JSON. So you can search by any fields. Just as a side note at this point, one of the reasons for using a separate database is that one could, the way IMUS is built is one could have multiple instances of IMUS all talking to the same database sitting behind a round-robin router. This way it's scalable because all state is stored in the database, and this makes it possibly scalable. So IMUS uses the Express.js library. It's a popular framework for building REST API implementations. And what happens is it acts as a web server. It takes the request in as the HTTP request at a port. And then it applies a chain of processors to that request. And so in index.ts, which is the top level of IMUS, it creates Express and then starts building this chain of request processors that'll process the requests coming in. Now each of these processors do things from logging, which is this Morgan call, does HTTP header processing, which is this CURS call. This is this processor says if it said its data type was JSON, it parses the JSON and adds it to the request body. And then at runtime, I dynamically collect all the routines that contain routers and add them to this processing chain. And so what happens when a request comes in, it starts adding calling these processors, this chain of processors on the request, until one of the processors says, okay, we're all done, send a response, and we're happy. Now, if the structure of IMUS is set up, this routine create API router walks this subdirectory, the specified directory, and finds all the routines that have routes in them. So the data structure here is, the directory structure is, so here's the routes first, stats and debug, and then routes last will be at the end, which is at the air. So this is routes last down here. And the regular route directory has this structure which is built around the types of requests that are the form of the request. So it's API v1, account ID field. So like if we go here, API v1 account ID field name, if we look in this file, we discover that here is the router that gets, if the request was to API v1 account with an account ID and a field and a parameter, it does this set of processors, chain of processors on this request. Here's a post request to that particular field. Now the way the router thing works is that each of these router processors gets called with a request, the request structure that's brought in, a response structure that is decorated and used to receive response, and a next function. So what they do, so what it does is it gets the request, it does whatever it wants to do with the request and decorates the response, and then if it's all done, it doesn't recall next. If it is done, it calls next, which does the next processor in the chain. So the way I've built IMUS is these chain of processors decorate the request. So since the request is passed to each one of the links in the chain, each of the processors in the chain, I add new things to that request based on what's needed. So in this case, we set up Metaverse API, which sets up the basic structure, the response request structure, and also gets the authorization token out of the header. Account from auth token says, well, if there's an auth token, look up that account. An account from params takes the account ID out of the parameter and looks that up and puts that on the request as vAccount. Param1 from params obviously collects param1 and puts that in param1, and then it says proc the get field. So we're going to do the get field operation here, and get field now has a request. So did I have an authorizing account? Yes. Was an account really specified? If yes, then get the field from the accounts. With the authorization token that was used to access this and the account and all the other parameters in that. And then what this does is it actually builds this adds to the data structure the response. The get field response will go into the data field. Then after the proc get field, we finish the Metaverse API, which says if there's data in there, it finishes it and it returns it in the format that it's supposed to be returned in. So this request here looks up accounts, checks for fields and that sort of stuff, and the processing of the routine actually does the request, gets the data that's going to be the response, and returns the response. If any of these didn't pass, it responds failure. It gives what went wrong, and returns that, and then it just calls next. So the processing is a post. He does, account validation and that sort of stuff, and then calls set field. And so all of these requests go from the simple ones. There's ones that are really kind of no ops, like this Commerce HF app, and there's over to the more complex one, like the get field ones. So there are a whole bunch of helper functions too that help out these functions. So if we look in accounts, we'll see that this thing starts out with these filters, these pagiation filters and account scope filters and account filter info, they call it. And these are helper functions that take the queries that are at the end of the request and figure out what is being asked. So like the pagiation filter checks for the page num and current page that you can put on the end of the request to limit the size of a query, because like there might be 1,000 accounts and you want the first 10, and so pagiation does that. There's ones for account scope and whether you're an admin account. There's some like for accounts you can say I only want the online accounts, or I only want accounts that are my friends, and these are these filters, and these are passed down into these enumeration functions as criteria filters. These are all of a class criteria filter. There's a similar pattern for all the other different entity types. somewhere up here is entity filters. There's account filters. There's place filters um, to be able to do that. There are a whole bunch of functions for looking up accounts and also doing permissions. So under Route Tools, there's a whole permission system with a set of permissions that you can specify to who has access to go and has centralized permission checking. So there's the permissions library has, or the permissions module has check access to entity, which goes through the permissions list and checks for permissions. Routines for building REST response, and that sort of thing. So we've in section 2 we covered the basic infrastructure, the Express.js organization, and somehow the requests are processed, how the requests are processed, and a bunch of the library routines that are there for processing requests. Okay, in section 3 we're going to talk about entities. So entities are the things that are stored in the database and that the requests operate on. So there are, at the moment, there are several different types of entities. They are accounts, domains, places, and tokens, and also requests. We can get to requests eventually. So each one of the things, like say we look at account. So account entity is just a structure that has top level names and values. So like it has an ID and has a username, the email address. The account settings is something that's stored by the domain server. It's images, has location information. So this is what an account, information about account that is stored. Now there's for each one of the entities, there's usually a triad of files. There's the entity definition itself. There's a thing called accounts, which is a class of functions that operate on accounts. So there are usually get operations, like get account with an ID. So given the account ID, find the account. Get the account with an auth token. An account makes a request to you and find out which account it is based on the who was logged in. Get an account with the username. The username is specified. Get the account that's associated with that username. Then there's also other functions that add account to the database, remove the account context, which is any dependencies that the account has, that things that point to the account. Update the fields, get a field for the account, set a field, and there's usually a routine that creates a new account that sets all the defaults for the structure, and then there's usually a series account or a series streaming operation that gets multiple instances of accounts based on criteria. Then there's utility functions, like accounts have these password stuff, so you have to hash the password and save it funnily. The accounts have friends, and so all the logic for operating on accounts are here in the account stuff. So the account definition had all these different fields, and then there's another file which is the account fields, which defines for each one of the fields find it, what the entity field is, what its request name is, that is what comes in the request from user requests, what the permissions are needed to either get the ID or to set the ID, what the function is to validate the value if you're trying to set it, and what a setter and getter function is for them. So some of them are like username can be gotten by all, but it can only be set by the owner, that is the user, or an admin, and the validation checks to make sure it's of a certain form and whether any other account has the username, and then it has a getter and setter. Email that has a validation is kind of complex and has a setter and a getter for it. Some of these, I mean, if you're setting a date, the simple getter and setter just sets the value. And these all validators, the basic validators, are all in utility routines, which is a set of, it has a whole bunch of different validators, and there's some of the values are arrays of values, and so there are utility routines for that. So this triad of files, the account entity, you'll see it happens again for domains. There's domains and field types and entities. So a domain entity consists of various fields. The domain fields defines each one of the fields, who can get them and set them, and then it has a set of functions: get domain with API key, create the domain, remove the domain context, get field, set field, and other checks for the domain. So there's a set for accounts, auth tokens, the tokens that are kept. There's the auth token is defined by the field, and then there is the tokens function for operating on tokens. And the same thing's true for place. So place has entities, definition has definition of all of its fields, and then has a set of functions that operate on them. Okay, in section 4, we're just going to talk about how you would add new features to IMUS. So to add new API calls, what you would do is, if you wanted to say API v1 places, you wanted to add a new function to places, you would create the file here, .ts, follow the form of the files that are here. That is, these are a bunch of import the necessary libraries and things, the processing routines, and then this little structure of a name so that it can print it out with the router. This is what it's find, and then define that router as the operations and the chain processing operations for that particular request. And voila, when next time you start it, it'll come and find this router and implement the operation that you need. Obviously, it's whether it's an HTTP GET, PUT, or POST, or DELETE is specified here. So this is everything you need to add a new request to the API. To add new entities, if you had wanted to add some sort of resource that all the domain servers can get at, obviously you copy what's one of the existing systems and or existing entities and start building from that. That is, if you're going to add a tree type, you can create a tree entity, define its fields, how to get to access it, and then the operations that you have on that tree type. Now, all of these things, when you do these, there is documentation for the different types of entities and the operations on them. And so whenever you either add new entities or add new operations, be sure to update the documentation. Finally, you can, all this project, all the code is under the license with all the rest of the Arcadia stuff is available on GitHub under the IMUS project on GitHub. You can, there's documentation on what was covered in here. There's documents in the document tree for the design and how routing works and that sort of stuff, as well as documentation of the API itself. So file issues, if you find problems, want requests, want enhancements, file issues on the GitHub project, and ask questions on the, there's a Metaverse server channel on the Vercadia Discord server, and ask questions there, and we can talk about the things to do with the IMUS domain server. Thank you very much for watching.